Deep in space are violent storms of gas, a dark force, and dust clouds so large that it would take a spaceship traveling at light speed 3 years to cross them. This storm of gas is the birthplace of stars. This is a huge spaceship telescope. Its mission is to photograph the stars in deep space. But this telescope has no rocket fuel. It is powered by one of the stars. This is all happening at the edge of a far-flung galaxy. A galaxy of millions of stars. The star that powers the telescope is small compared to some of the stars in the galaxy. But at its center, it is hot. Millions of degrees centigrade. This is because the star is made of exploding gases. These explosions create a lot of light. Close by, there is a small planet. Well, when I say close, it would take 8 minutes by a standard Lightspeed Federation spacecraft. Without the star's rays, the planet would be bare, and the planet's life non-existent. But the light of the star is so fantastic that it warms up this planet. The rays of light are not actually hot, but they warm up whatever they touch. The light stirs up atoms. The atoms move faster and make heat. This light means that the ice becomes water. Plants can grow from rock. And animals can live off the plants. On this planet lives an intelligent life form. Although these creatures can't yet reach the stars, they can send rockets into space.
T-minus 17 seconds and counting. The body flap and speed brake are in launch position. T-minus 10, 9, 8, 7, 6. We go for main engine start. We have main engine start. And ignition. And liftoff. The shuttle has cleared the tower.
Does this planet have a name? Yes, it does. We call it the Earth. And we call the name of its nearest star the Sun. Over the years, our rockets have launched many satellites into space. Some of these, like the space station Mir, have carried people. Others contain cameras for some countries to spy on other countries from space. These cameras are so powerful that they can watch armies and secret bases on the planet's surface. The satellites are also used for peaceful purposes, such as looking at the weather and beaming down TV programs. All the instruments on space stations need electrical power to work. This power has to be made in space. These wings are capturing the light from our nearest star, the Sun. They are converting the light into electricity. This electricity powers the satellite. The wings are made up of thousands of tiny cells. But how do they make electricity? Each cell is made up of extremely thin layers of light-sensitive material. When light falls on the surface, it makes electrons jump from the top layer to the bottom layer. This generates tiny amounts of electricity. The electricity is not enough to power a light bulb, let alone a satellite. So they have to join thousands of these cells together.
5, 4, 3, 2, 1.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Stardate 1990. In this year, the huge spaceship telescope Hubble was launched into space. Once in orbit above the Earth's atmosphere, it began to photograph the stars. All this time it was powered by solar cells. Solar cells that make electricity from the light of the sun. These solar panels can generate enough electricity to power 4 electric fires for 4 years without stopping. The cells can only make electricity when the light of the sun shines on them. Although the sun's light is very powerful, it only travels in straight lines. Because of this, the spaceship's computer has to point the panels directly at the sun. This means that it can be blocked by things that get in the way. Things like the Earth. It has done this for the last 4 years. But now there are a few problems and the cells are wearing out. It's time to replace them. The solar panels are made on the Earth's surface. They're also carefully tested to see if they work properly. Any cracks in the cells make them useless. And they also need to be checked to see if they respond to light. If all the cells are okay, one final ground test. Will the robots open and move the panels properly in space? You never know with robots. Well, everything works on the ground. It's time to get these solar panels into space and call in the maintenance crew. It's not exactly scramble the X-wings, is it? This flight needs months of preparation. Ready? Okay, here we go. 5, 4,
3, 2, 1. Ignition and liftoff. Discovery now on its way to service NASA's Hubble Space Telescope.
The maintenance crew's spaceship doesn't have hyperdrive, so it takes them 8 hours to reach the space telescope. Once they are there, they unscrew the old panels and remove the old energy cells. Then they put the new ones in their place. This is all done in space, traveling at thousands of miles an hour around the planet below. The new panel should last another 4 years. The energy from the sun will last at least another 50,000 million years. So as we have the technology to get free energy from the sun, do we use it on the planet's surface? The answer is not a lot. Most of the power and electricity on the Earth comes from burning coal, oil and gas, 1 million tons every hour. This fuel is expensive, causes pollution and global warming, and cannot be replaced. So why don't we use more energy from the sun? It's not as easy as it might seem. Remember, the light from the sun travels in straight lines. Because of this, half of our planet is in the dark, at night. Unfortunately, this is when people want the most power, for heat and light. Even in the daytime, there are problems. Rays of light are stopped by tall buildings. These would cast shadows on the solar panels. Even when solar panels are placed in flat areas, clouds can stop the light from shining brightly on them. And when do we get the most cloud? In winter, when we need the most power. The best place to build a power station that uses light is in the desert. The problem is that people need water to live, and most of us live in cities that aren't in deserts. That also brings another problem. A large city would need panels of cells taking up as much room as itself to get enough power. So at the moment, only 1/100th of the power on Earth is collected from the light of the sun. But in the future, all this might change. One idea the scientists have is to build a huge space power station with panels miles across that would beam the power to the Earth's surface. This project will take many years to plan. But another idea is already being built. This is a giant mirror that will be controlled by the Mir space station. The astronauts on the space station will point the mirror at the sun by remote control. The light from the sun will then reflect down onto the surface of the dark side of the planet. If the astronauts point the mirror carefully enough, they should turn a small part of the surface of the planet from night into day for a few minutes. Meanwhile, we are still using panels of solar cells to power our spaceships and satellites. Satellites such as this one, with its powerful telescope that is exploring deep, deep space. For the planet Earth and the Space Telescope Hubble are still orbiting the sun, our closest star. And that star is still shining brightly in its far-flung galaxy. A galaxy that shines with light fantastic.